Recording started.
Okay, can everyone hear me okay? Awesome. Okay. So, as you probably know, I have finally finished the marking of assignment 1, and you should be able to find your raw score out of 15. Well, your score out of 15 after any penalties have been applied, markdowns for being late, etc., should actually be in Blackboard as we speak. There were 43 submissions, and just give me one moment and I'll actually give you a breakdown of the results. Actually, I'll turn, just give me a sec, I'll just turn the application sharing off while I load it, because otherwise I'll be giving out people's personal details. Hang on. Okay, back again. Can people hear me okay? Okay, so let's now see if it'll actually let me do some application sharing. Okay. Okay. Now I've got this graphic in my way, but anyway, we'll manage on. It's the actual graphic for the plugin, which is supposed to be helping me instead of being in my way. Anyway, so the average mark, this is really low, and I'm really quite concerned. The average mark was 56%, and the pass rate was 60%. You can see that the highest mark was 99. The lowest was a 0. Now the 0 mark is because the person submitted late. So basically all of the marks that they would have gotten if they submitted on time were cancelled out by their late submission. Yes. In one particular case, a student got 36%, but because they were 4 days late, they got docked by 40%. Now, I'm not going to allow people's assessment to go into the negatives, because you should at least be able to clean slate with what you have. Therefore, yeah, there was a couple of students in that case where basically they lost all their marks because they submitted late. And basically I applied the late penalties. That was the last thing I did before I released the results. But I've got to say, there were about, out of 43, there were about 5 submissions which produced 0 output. So I ran the program, it did nothing. And there was another 5 which had very little in them. So about 1/4 of submissions had very little for me to mark, so I had trouble marking them. And I'm sorry if you were one of those people, but I can only work with what I've got. So that was a bit disappointing. I've taught several times over summer, and the averages were generally better there. So not quite sure what the story is. Those of you who scored poorly, please contact me via email. And when I say poorly, my view is that if you got below 60%, so out of 15, that's really, say, what is that? Equals 15 times 0.6. So if you got below 9, we're in panic stations. So we need to kind of, if you're in that situation and you're really wanting to make up marks, talk to me via email and I'll see what I can do. I will have to talk with the AUA coordinator about what kind of things we can do in terms of it, but if you're in that situation, and there was 40 or more percent of you who are, or 40 or so percent, then we need to talk because I don't want you to fail. I have no desire for you to fail whatsoever. But having said that, I want people to actually be able to show what they can do. And keep in mind that there is no hurdles. So you could make things up on the exam, but guess what? Because the exam is not a hurdle, it's actually probably going to be a harder exam than if it was a hurdle. Because we want to make sure that people who get through this course are able to do the skills which we say that people who come into this course should be able to do. A lot of people, well, I had someone use GetS in the assignment. Do people remember me talking about GetS at all? Correct. You should use fgetS. For one thing, GetS has been used to break computer security. Because you declare an array of a certain size, you go outside the bounds of that array and you could inject additional code. Which when the program returns, it looks at that address, goes up there, and gives people access to things they shouldn't have. So it's very dangerous. And it's also, we had people using scanf, which once again, you were told not to do. But what I had a lot of people doing is not testing the return value from fgetS. So what can't you do if you don't test the return value from fgetS? It's not so much that. Remember the quit requirement. Something to do with the quit requirement. Correct. Now, what people were doing was checking whether the new line character existed in the string as a way to check for control D. But guess what? Control D will return null and leave the character array unmodified. So there may in fact have been a new line character already in that buffer left over from whatever that memory was last used for. And so the only reliable way to check for Control D is to check that the for a return of null from fgetters. Other than that, there were a lot of well, if I just hang on a sec, just have a look at this. So I can actually have a look at responses in a reasonably anonymous way. So initializing the board game, pretty much everyone did that, right? Although it was hard to get wrong, although there were some people who managed to do so. Like for example, they used well, one thing was to call memcopy. So let me just show you actually. Let me just say okay, and say I've got let's do ints because it's just going to be quicker. Int array. Now you should in your code be using hash defines. I'm just doing it this way because I'm in a demonstration. And let's just say orig 8 equals, and I'll just set it all to be 0. I mean, obviously in the version what we were doing in the assignment, I gave you a board, but that's so say in int main void, right? And I've got this array. Now, the right thing to do, and I did demonstrate this, memcopy array orig. Now, because I've got both array and orig on hand, I could use size of orig, but I can also do size of int. Right? Because what's special about array elements in terms of where they are located in memory? In relation to each other. They're right next to each other. And we know how, okay, so you could use that, but here's what some people were doing. Okay, I'll use 8 here, but you used board width in yours. Actually, I prefer to do that. Okay, and yep. So now what the people who are doing stuff kind of using a loops, and they did stuff like array j I equals orig j I. That was fine. I gave that the same marks as the memcopy version, and this, which is weird, but okay, I had people do in the version I had with enum, using the enum cell. Here I'll just do int because I'm using it. Now, can someone tell me what's wrong with this code? It will work, but sometimes the question that something works shouldn't be the foremost thing in our minds. Doesn't it seem a bit pointless? You've already got this loop here, and if assignment works, then well, that's the end of that. Having said that, this got full marks. What didn't get the marks was, I saw people do this as well. What's wrong here? Yeah, but I really, yes, so what does this 8 then mean? If this is already a 8x8 iteration, what is the result of doing this? Right, so what's that mean though in terms of the memory on the machine? This is actually fairly important. Yes, but just imagine right now that J and I are both 7 right now. What does this mean? Right? No. I'm thinking about if we are copying to array 77 from orig 77 and we're copying 8 bytes. Right, we are copying data from somewhere else and we are overwriting that data in array. Now in this particular, so if in fact these were next to each other, if I actually had this kind of thing, then it's quite possible that I could be overwriting the data in one array with the data from the end, beyond the end of the other array. Right? So if these are next to each other, it's quite possible that when I'm writing into array, I'm actually wiping out some of the data from orig, because they're just bytes slapped next to each other. Does that make sense? We asked for 64 bytes of one thing, and then, well, 64 times 4 actually, because they're ints. So we asked for 64 int slots, and then we asked for another 64 int slots, which are right next to each other. Correct. All kinds of nastiness, right? So there was that. There were people who didn't print out the color codes, so they lost a little bit for that. But most people got those first two requirements. Like even like people who got like say 10 or 15 out of 100, they got those first two requirements. So that stuff was reasonably well understood. Like some of the depth about how you can do things wrong, sure, that's why you're here, to learn that, right? And if anything I say here doesn't make sense, please ask. But yeah, that was one issue. So yeah, here's an example of where I'm talking about the mem copy being a waste of time because they're already doing the 2D iteration. By the way, mem copy is so much faster than string copy. In fact, the implementation of grep in Linux uses mem copy, and it can copy over a gigabyte of data per second through in the memory, whereas string copy, it's only about 100k per second. So not that you really need to know that, but that's an interesting thing to know. Yeah, so there is a few examples where I'm going, I showed you this stuff in the chats. So there is an element of, particularly when people are missing points, which I've gone through in the chats and stuff, whether people are actually watching them. But yeah, the contradiction is me raising this as pointless because the people who aren't watching them won't be watching this either. Alrighty, so display game board, once again 68% got that, and there were some people who weren't actually reading from the board array, they were just printing out what the board would look like at startup. People who implemented stuff but never ran it, so I don't know whether it actually runs right or not. It was never tested. I had people who had variable names like A, B, C, D. And I was like, I can't understand what you're doing here because the variable names are meaningless. Okay, initialize player. So there were some which didn't compile. Now if people use malloc and the program worked, I let that go because the second assignment uses malloc. So people not understanding the arrow versus the dot, but no marks were taken off for that. One issue that I did take off marks for was declaring an array that was too small. Or too big. Because we know that we got namelen plus 2 chars, right? That's the space we need to allow for FGetS. I also took marks off if people were passing the player name directly into FGetS. Why is that a problem? The player arrow name, if you pass that directly into FGetS. Is this something people should know? Okay, let me just... So, let's just go to shared. I bet you didn't know you could do that. You open a zip file in Vim. Actually, it's in the H. So, how long is player name in the struct? Correctamundo. Why is it too short, Paul? Right. And so if I actually did enter a name which was 20 chars long, then I could be overwriting what's next door. I only add one here because a valid string just needs a null terminator. But a string passed into FGetS needs space for the new line character as well. So there's that. Okay. Most people did player init fine. And in fact, their player inits weren't all that different to mine. They might have actually had, like current player arrow score equals 0 and that kind of thing. That's fine. There were people who tried to declare 2 player structs inside here for the 2 players and initialize the 2 players, which meant there was no way for them to get that data back to reverse play game. So that was wrong. Some people didn't handle quitting very well. In particular, they didn't know how to handle the Control D. So you see here I have result equals IR RTM. And now, hang on a sec, I'll just close that. And we'll have a look at read string from keyboard. Which is in helpers.c. The only annoying thing is that, of course, these are not actually sorted, which is incredibly annoying. There we are. There we go. Okay. Not just. Okay, so I can go back there if I need to. So read string from the keyboard. So I test if fgetS returns null. And if the first element in the string is a new line, it also returns at IRRTM, which I then handle in both let's see, in with player.h, I just, if the result is IRTM, return, and so that's an indication a player has decided to quit. Yeah, and people got player turn right mostly. If they gave it a go, then they generally got it. What they didn't get so right was apply move. And people did stuff like only checking horizontal and vertical and not diagonal, or they rejected lots of valid moves, or they failed to reject invalid moves. That was less common. People tended to do the rejection of invalid moves, they tended to reject invalid moves, mostly correct, but what people didn't do was accept valid moves correctly. And you can have a look at my version of that for that. And people had lots of really kind of dodgy code, like the code wasn't very good in terms of things like variable names like P and Q. I wasn't quite sure what things meant. It made the code hard to follow. Yeah. Okay. So I might leave that there. Any questions about this? You'll probably have more questions once you actually get your feedback. But people who gave the assignment a good go, I think, generally did pretty well. And in fact, there's about 1/3 of those who attempted the assignment got a high distinction. So there's lots of really good assignments and lots of assignments where people didn't get very far as well. So if you're one of the people who didn't get very far, or really if you got below 60, please contact me by email, and I'll see what I can do in terms of I have no desire to make you fail, as surprising as that might be. I am in fact very keen to have people pass, but have people pass through knowing the material. Yeah. So any questions? Oh, by the way, you might get some comments which surprise you from the point of view that I have a technique. I've decided to actually mark people now using a kind of a blind marking method. So I actually try to ignore your name when I'm marking, to be as even-handed as I can possibly be. So there may in fact be some comments I've made when marking your program where you're like, hang on a minute, you know that that your comments aren't the same as what is. But basically my comments were based solely on looking at the code and my impression of the assignment. We may have a history in terms of support I've given or whatever, but I ignored that when marking because I think everyone should be marked on the strength of their submission. Okay? Yeah. I've noticed that, like, because I work in various different places teaching, I've noticed that some places now require this kind of double blind marking, so that you aren't biased by the fact that someone was one of your students, or you built up a strong relationship with, went down the pub with, or had footy with, or something. But yeah, so that's and like I was very pleased with a lot of the assignments. I might just very briefly show you. If I go into this is my repository where Git repository where I actually develop my code. So if I go into A1 solution, okay, so I actually built a script which ran my program. And I got this kind of output, and I actually marked, if your program didn't work with my script, I then marked it by hand, but generally I tried to get my script working with your program first. So here's what that looks like. And so for things like line length, or if there are words that I was trying to avoid, like I did a search for getS, but it will do fgetS because the F is there. But anyway, and for like buffer overflow, I essentially inserted lots and lots and lots of spaces as the name of a player, and it should complain about too much input. Okay. And I entered in things like 9.3 as a coordinate, and 9,3, and invalid coordinates and that kind of thing, as well as coordinates which weren't, like we're currently blue, so 6,5 wouldn't be a valid move, and that kind of thing. It's just a Python script I've written that does that. I mean, I don't want, yeah, sure. Absolutely, I have nothing to hide, so I don't want to spend time on it here, but I can zip this up, and it's this R tester. So I have 2 runs of Reversi, one which was provided by Paul Weston, and one which I created myself from script. And if your program behaved well for both, then it was valid. I'm not going to comment this, so if you're really, treat it as a black box and test it with your program if you like. And I'll probably build on it for assignment 2 marking, but I'll just remove the reversi here, then zip, and I'll copy that into shared. So you'll be able to copy that. You won't be able to open it inside that directory, but you'll be able to copy it to your home directory. Yeah, I'm using a library called pexpect, which just basically sends and receives messages from your program. I tried to be as generic as possible. Yeah. Okay. Now, I spent a long time just then on your assignment, but that's for one very good reason, actually. One, I wanted to give you the fullest feedback I could. But there's another reason. That's because I realized when going through the cheat sheet, this is stuff I kind of covered a bit last week. So it's up to you whether you want me to go through this or not. But it's would essentially be revision on the stuff on makefiles. This time I wouldn't really go through it with code. I'd more talk through it because you've got the code from last week. Yep, sure. So, normally with GCC, and let's actually use my solution code. So, okay. So, GCC minus E oh, what was all of that? So that was, if I just run the preprocessor, right? See, this is, as you would know, this is the file. Well, what's happened here, though? Correct. And it's also, so what then is all of this? This goes on for ages. Not part of my code. In fact, if I do a word count based on lines, 3003 versus word count 17 lines. Correct, because hash include is literal. Everything about the C language is literal, and that's what a lot of you struggle with, actually, is the literalness, literality. I don't know what the word is, but the fact that C is a very simple language, and that's what people struggle with, is it is so minimalist, and there's a certain element of trust in the programmer that goes on with C, just like trust in Linux. The assumption is that the user knows what they're doing. So that's the first stage, is we replace all the hash stuff, right? So we replace the hash includes, we replace the hash defines, and there are others as well, but they are the two big ones, the hash includes and hash defines. So, and it stores some references to the files which are involved. So you see here, these are all the files which are involved in reversi.c. Yeah. Okay. So that's the first thing, is pre-processing. Now, the next thing though is the code gets parsed, right? So every file gets processed from top to bottom, which means if we've got or something like that. Right? What's going to happen if I try to compile this? And I'll give you a clue that the file name that I gave the file is a big clue. Yeah, basically it's a single parse compiler, which means it goes from the top downwards. Okay? And so this will compile, actually. My typing won't compile, really. So, warning, explicit or implicit declaration of function do it, but it did compile. Doesn't do anything useful. But, so, that's one of the things is that, so what the compiler does is it actually creates a little map of all the symbols that we've used in our program. And it validates that each sequence of symbols is a valid statement. Right? That's why we need a semicolon at the end of each line, etc., etc. Languages that don't do that have to bring in some other mechanism for defining the end of a line. You know, like Python counts white space. I know very little about Swift, sorry to say, Paul. I do know in Swift that the series of arguments passed into a function is itself a type. It's kind of like a tuple kind of thing. And that's borrowed from functional languages. But anyway, it's neither here nor there. So, but let's go back to my private Git repository. Okay, so GCC minus S on reversi.c. Okay, so once we've parsed the file, we've gone from top to bottom, we've built up a map of all of the tokens. The tokens are the separate things like the equals sign, the variable names, the semicolons, and so on. The code gets assembled. Well, gets converted to assembler. So that's what I just did. So you see we've got this reversi.s here. And in fact, this is the assembly code generated for the reversi.c file. So it has things like, here's the definition of our main function, and there's lots of pushing of values onto the stack. And we call the function reversi play game. So that's the assembly code that gets generated for each of our C files. Right? Okie dokie. So that happens. But then after that, we actually, so that's kind of, the next thing is we compile that assembly into a object file, a .o file. GCC minus C. So I'll do this. So these here have to do with individual compilation of each file, because they have to do with the rules about parsing. So technically I should have passed these into the to generating the assembly. But anyway, so minus C reversi.c. Alright? Now that generates an object file. So we have a reversi.o. So if let me just do a make clean. Maybe if we actually learn to spell, that'd be good. So this here, we're going to compile. So this is each individual file has to be compiled. Like so. Right? So now, you see how okay, so if we go into reversi.o, this is in fact a the binary executable for one, the binary code for one module, the reversi.c module, right? It goes on for a while. This doesn't mean anything really. Okay, so if we were so inclined, we could in fact go through and look at the bytes one by one and what they meant. Let's not worry about that. But you can see that's one way you can examine your binary code. But then, if we look at what you've done in the past, like this, right? Let's break this up. So that's what you've done in the past, right? So that involves an awful lot of things, doesn't it? So for one thing, each of the .c files gets compiled separately. Yeah? So what happens, right? Okay, let me just do that. So I'll just do minus C. Right, they're all the object files. Now, I can feed these object files into GCC and then get them to generate an executable. So my question is, do I need minus ANSI when I am doing this? Okay, the next question is, why not? Yeah, the ANSI standard has to do with the syntax. And we parsed that and we created binary objects. So now there's no parsing of source to be done. Right? So what I could do is gcc star.o minus o reverse it. And just a reminder what star dot something expands to. I just echo that out. So it just expands to all the... Well, they're all got to do with the parsing of source. So in fact, when you are compiling your program, the linker phase, which is what we just did, was in fact we called something called LD. In fact gets called as part of linking. And you might remember that actually last week I spoke about the LD flags. That was about the linking. And in fact, let me just if I you notice up here, this is the linking target. Yep. And there are no ANSI pedantic. They're not to be seen here. But they are seen down here because C flags. But you might have some linker flags, LD, linker flags, and you might pass them in here. For example, this is specifying to link in the math library. For example, if I was using square root or POW or some other function from the math library. Okay. So just having a look back here. So what's this about reduction of compile times, do you reckon, with makefiles? Yeah, so, you know, yeah, so in some ways, when I have targets like this debug, where I'm adding G and then I'm saying delete and recompile, kind of defeats the purpose a little bit. but really big projects like GCC is pretty big, and what I got my students to do last year in the Unix system admin course was to actually compile. One of the things I had to do was compile GCC. Which meant leaving the actual make for GCC takes 6 or more hours. So I don't really want to have to recompile the whole thing when I've made one update to the GCC source. So I guess one other thing is, it'd be good, like, can you point out what the components of this makefile are? Like, what are the bits? People should be jumping on this one. We went through it last week. We're having just a couple of people who are the same few who are contributing. We're a team. Yep, so we have variables like these fellas up the top here. We've also got some built-in variables here. So, yep, we've got like the $ less than and the $at. And we've got, so what are these things in blue called? Yeah, they're the targets. So you can see, so therefore what's on the right hand side of the, so we have a target name, colon, but what's on the right hand side of the target name? Well, it's, wait and see if I get, Yeah. The common names that I've heard are dependency and prerequisite. So the thing which must exist in order for this thing to be done. So in this case, all depends upon person list. Now person list depends on whatever's in objects. So that's list.o, person.o, main.o. Okay? And then whatever is indented by the tab here is the things that they're the commands which are done, if you will, the implementation of the target. Probably the only other thing is I do expect a clean target, and a clean target should always work. It should never throw an error message. So what do I mean by that? What happens if I delete this -F, do you think? Any Unix bods in the house? Well, it will fail if there are no .o files or if person list does not exist. Because -F says, just do it, don't complain to me about nothing. Right? So a common error. Okay, I'll make sure that this will fail. So I'm going to delete all the .o files and then type make clean. So cannot remove star.o, no such file or directory. But if I add that -F back in, now what I don't want to see people do is this. And hopefully someone can tell me what's wrong with this. Say. And people who are copying stuff off Stack Overflow, yep, I see people do that all the time, right? But it still fails, right? Which means, for example, I'll show you what the problem is. So let's just ls. I think this will work. So, for one thing, we've now got this error message here. I did delete person list, but anyway. A proper clean looks like this. Now you can hide the output just like I have up here with the @ symbol. So if I had this, now you'll no longer see the rm-f command. But it will have done it. Ha! Learn to spell. Ah, yeah, I remember. There were some issues. with list print. Yep. Okay. Let's just comment that out so you can actually see it compile. Or even better. That's a way we can actually have nesting hidden code. Yeah, let's not worry about that. That code was never meant to run anyway. It was just an example. Yeah. So, William, what was your question about the clean? I don't care. Really don't care. Some people prefer it, think it's neater. I don't really care. Yeah. That's all good. Okay. So that's the make file kind of, yeah. Let's just see if there's anything on here that. Okay. What's a phony target? Look, that should be PHONY there. Sorry about that. So what's a phony target? Yes. Now, as you can imagine, well, what do you think about a program called make? What do you think its purpose is? To make stuff. Does clean make stuff? No, it deletes stuff. So one of the things that make does is it checks, right? Remember, it checks. Is the modification date of the compiled object file older than the .c file? If it is, you remake it. But there's no file called clean here, is there? And so making something a phony target says to make, hey, this doesn't really make something, just run it. So that's essentially a phony target. The only other thing you might find useful is the fact you can actually have targets which which change the variables involved. So here I have debug add C flags minus G, and I might even do this, right? Minus D D E B U G. So what's that do? Minus D debug. I've done this in your startup code, in fact. Or you will need to do it. Yep, correct. So what's that do? Right, it's the equivalent of a hash define at the top of every file. Or the top of the, yeah. Yep, correct. I find that very powerful. But yeah, look, you don't need a makefile like this to actually pass the assignment. You can in fact simply have, say if we've got list.o, which requires list.c and list.h and person.h and bool.h. And GCC so they're equivalent. So that this is equivalent to one particular expansion of this wildcard target. But you can do either. I don't care. The wildcard approach means less work for you when moving between projects. Like pretty much I can change the source files in this makefile and everything else just works. I just change these variables at the top and I don't have to change much else. Oh, maybe I shouldn't have told you that. But anyway. So the makefile thing is not a huge requirement. Shouldn't be too big a deal. Okay. So look, I might just leave that there. Any final questions before we head off? So yeah, like I said, I will send out an email this evening with your marks for or your feedback for assignment 1. Basically, I have all of that in a spreadsheet, and now I just need to put together a merge email to actually send that stuff out. Okay. No worries. It's really, really important for people to be on top of their assignment. So I'm hoping everyone is pretty solidly into assignment 2 by now. Because it's actually bigger, really. Ah, okay. Awesome. Well, you know, but we'll have people at different points depending on what else they've been doing and stuff. But really need to get onto it now, really. Yeah. If you haven't already. Okay, so I might just leave that there. As usual, if you're having issues with the assignment, start with the discussion forums. And if it's a little bit more personal, if there's code involved, email me. And I wish you all the best.